This is Andrew Salami, and my final project, I built a financial tactical asset allocation tool for US equity markets. My broad goal here was to use deep learning techniques and try to predict near and medium term forward returns in the S&P 500 index. And that varies between 1 to 3 months is what I mean by near and medium term. The data I used from multiple sources and basically consisted of broad market measures of macro and fundamental time series data, from macro categories such as sentiment, liquidity, valuation, technicals, fundamentals, risks, and economic data. All in all, the first few runs had about between 80 and 100 features going into them, but depending on how I set it up. And the techniques I used, the first one was a feed-forward regression. Obviously, no memory or sequencing there. And the second technique I used was an RNN, specifically an LSTM, where there was sequencing and memory invoked. Again, the goal is to predict the S&P index forward returns in order to for people, either individual investors or institutional investors, to modify their portfolios in a tactical manner. And by tactically, I mean 4 to 6 times a year to reallocate their portfolios away from stocks and towards other things, or in the case where it looks like the forward prediction is strong, to allocate more towards stocks in a more meaningful manner on a quarterly or slightly more than quarterly basis. Pretty straightforward on the technology. I use Google Colab for the whole project. My computer, I was using the GPU, obviously. My computer is old, you can tell from the description here. But just because I didn't have time series data was, at the end of the day, all made into daily frequency. Even so, there isn't a ton of data, so I could run this on my GPU just as well as on my CPU, on my old computer, as well as the GPU. It took a little bit longer, but it wasn't disqualifying for the CPU. The data sets, again, multiple sources. Data was stored in CSV files by frequency, so I had a daily, a weekly, and a monthly file with data accordingly in them. And some of them had longer history than others. Some went back into the 70s. But for the most part, the data all kind of got to a critical mass around 2010, which is where I started the modeling at. Again, the listed categories, the categories of macro and fundamental data that I think are relevant to predicting the S&P. Important point here in handling the data and cleaning up, I spent a tremendous amount of time, and it's on the data part, mostly sourcing it and then getting it back historically far enough and figuring out ways to get it what I call at least in spirit point in time. I didn't use literal point in time data, but the data, obviously there's a lot of difference on some of the data series between when the report date and when you actually knew the known date, I should call it. And so I'd spend a lot of time getting that correct because you don't want to have any forward bias. And then also avoiding data that had revisions to it. In true point in time, that wouldn't matter. You would incorporate the revisions, but I didn't do that. I just made sure the data didn't have any revisions. So hopefully all the data is accurate. You knew it at the time that I have it in the databases. I did a lot of transformations. There's about 50 names, 54 features, something like 50 to 54 data series I used. And I did transformations on them and normalization and things like that. For normalization, I used Z-scores on everything. And, there's no doubt there's correlation between a lot of this data. And you can't help it. Valuation data is related to liquidity data and interest rates and things like that. It's natural, but at first I didn't care so much about that. I sort of put in a lot of things that I thought had a strong hypothesis of predicting S&P, and I said I would deal with the correlations through regularization and dropout layers and things like that. But towards the end, I ended up eliminating redundant features, the ones that had the most correlation, and just to see if it would give me different results. Again, this is a list of the data by category, sources and frequency and start dates. Again, there's slightly over 50 names. Top of the screen here is economic, ISM manufacturing. So just for example, I would take that data series. I would say, probably level is important on that as well as trend. I would create a level and a trend transformation. I would then normalize that data. So a lot of these data series had, at least at the start, had inclusion in the inputs in more than one way. So the first method I used to predict the forward S&P returns was a feed-forward regression. I used a rolling walk-forward approach where you train, validate, and test, and that sort of mimics how a real strategy was done. I did this in several different ways. You'll see in the coding. At first, I just did train and validate, and then roll it forward, train and validate again, creating a series of independent models. And then at the end, I tested on holdout data that I kept, holdout test data from 2022 to 2025. That created its own issues in that when I went to the test part, every model was making a prediction for every period, and then by using the ensemble prediction, it really just crushed the volatility down to very low, and so the magnitude of my predictions was nowhere near the magnitude of the actuals, and so that was problematic. And then I went back and did the training, validation, and test. Rolled it forward, did it again. So I had a series of tests that I could then look at and take an average of those. Method 2, I used an RNN, specifically an LSTM, and I did the same approach, walk forward approach, but obviously with this method, you're using memory and sequencing, and I thought that would improve the model. It did not. As far as fine tuning, my biggest opponent that I'm still trying to conquer is overfitting. And so, I handled it in many ways. I used L1 and L2 regularization, dropout layers, early stopping. I eliminated correlated features. And so by the end, again, I started with about 80 to 100. I was running models with about 17 to 20 features because I was just keeping the core most important ones, or ones that I had a hypothesis about. Again, at the top here, although I'm talking about 3-month forward predictions, that's for these macro data, that's, I think, the sweet spot in that range. But I did want to try other things. I tried 2-week and 1-month forward returns. I think those are a lot more random and harder to predict. I did try one run with 6-month returns as well, but I think 3-month is where I've always, I'm in the financial world professionally, and that's where I've always thought these features were strongest at their predicting. So here are the results, not great. So I did, I bucketed these after I ran the regression. I used backward-looking quantiles to measure where this prediction fell in versus where the actual fell in, and it wasn't great at predicting anything really. Maybe a little bit on the bearish side, it was able to do an okay job, but there are reasons why that number looks better than the others. Just kind of skewed everything that way. And it really is the overfitting. It was constant. Every step I took in this fine tuning helped. It really did, but it was always at the margin by a little bit. So it crept up, as far as results, but it never got to it. The overfitting was just there all the time. And let's face it, stock market returns have a lot of noise in them, and a lot of the movements that are happening are random and are not being accounted for in my data. But the feed forward was the best approach, I think, for this because it's simpler and because just the way it's handled. But all is not lost, because when I look at some of these charts, they are not bad. Like this is just 2014, the first prediction year. Yeah, it's a little squirrely in the beginning, but other than that, it's capturing the pattern, if not the scale. The predictions were much more conservative than the scale of the actuals, and I've got to look into that a little more. But this isn't terrible for that year. Here's 2015 to 16, and the same sort of thing. Yeah, there's a period there in the middle where it's under predicting, but for the most part, it did a really good job. This is most recent. This is 2020 to 2025. Now, this is a tough period anyways because of COVID and then the craziness in 2021 and the speculation, and then, of course, the Fed policy, which really hammered the financial markets. So, unfortunately, this doesn't look great. But what I am impressed by is the way it did sort of capture the 2020 bounce. You see the prediction is way up there as well as the actual. So it did see that coming, which is not a lot of people did. Also here in most recently this year, the markets did pretty well after the election, and it sort of captured that. And then when liberation came today with the tariffs in April and the market went down roughly 20%, it seemed to capture that. So it didn't seem to get a lot right, except for the two most important events in the last 5 years. So that's promising. And I think there's a lot of promise here to do more work, which is what I plan to do. Again, I spent so much time getting the data from all the different sources. I didn't have just one data source. And it took up a lot more time than I thought, and cleaning it up and getting it to point in time, known date being correct. That I wish I had more time to do more of these tests and figure out how I can improve this. So, in summary, my biggest problem was overfitting, and it showed up in every validation, and everything I tried, I couldn't get rid of it. It did get better, but at times, but it never was anything like I expected. It was just way too much, and it could be due to the randomness of the financial markets. It could be my features. I just have to explore that more. But the forward feed, the feed forward regression was the best. Again, I didn't see too much difference in using the 20 uncorrelated features than using the 100. So what that tells me is that it's better to do a more stringent and efficient feature selection prior, because it doesn't hurt the results and it's cleaner to do that. As far as future research, I plan to continue to explore this because I like some of the things I've seen. It obviously didn't test well. I don't think bucket testing was the right way to go, because once it seemed that the predictions were a lot more conservative than the actuals, and I've got to figure out why that is. And so the bucket test just got skewed. And the way I've used this before, used ideas like this before, it may just be a better warning sign. It may not ever be able to predict, or it's not maybe built to predict when there'll be smooth sailing and when there'll be great returns. It may be more of a model that warns you when things are going to get ugly. And that would make sense. In a tactical model, that's exactly how you'd use it, because you don't really want to change your portfolio in general that much, unless you see warning signs kind of coming, and then maybe you want to make a more allocation to things like bonds and cash. Anyways, I enjoyed this thoroughly. This was a great learning experience, and I thank you for your time.